Okay guys, today we will be going through your BC Week homework. So your term test is on the coming Monday, so I hope you will watch this video and understand what are the common misconceptions you have made. So firstly, your term test topic is from forces, vector diagram, F equals to ma, sound, current and electricity. This one is for the first chapter of electricity. That means V equals to E over Q, I equals to Q over T, how to find effective resistance, those things. Then we are going to do pressure. I think for the 4 and 2 students, you will definitely need to read the textbook because for the 4-1 I cover quite a lot, so they are ready for the O-level syllabus. Then the electrostatic that we cover recently. Okay, so for the first question, most of you have no issue plotting the points, but when we are dealing with best fit line, what you need to do is you need to draw the line in between the points, not on the points. So for example, when I do this, okay, you can see that I didn't draw my line on the point. As long as the line is in between the points, this is what we call a best fit line. So you can see down here, my line is in between these 2 points, and then my line is in between these 2 points. Okay, and it is just by luck that my last point is on the line. Okay, it is not necessary. This point can be slightly further away, not necessary to cut 0. I repeat, not necessary. Then next thing, when you are calculating gradient of the graph, remember you are not allowed to use the experimental data. Okay, this is what we call experimental data. Okay, this is not to be used for any calculation. So why am I saying that? Because some of you, when you are calculating your gradient, which is equals to y2 x2 y1 x1, right? When you are doing that, you tend to substitute these values into here, okay, which is wrong. You cannot do that. What you need to do is that you need to go and look at your graph and maybe find a point. So let's say when I look at the graph, I find that this point here is of interest to me. I want to use this point. So I will take this and I will read off, this is 15, 30. So I will use this as one of my point, and then I need to find a second point. So usually I will look somewhere here. So this one looks quite good. This one look like, okay, maybe this guy. This one down here, okay, is about 3, 5. So once I identify these 2 points, I will substitute this thing in. So I will sub in 30, 15, 5, 3, minus, and I will get the answer. So this one, use your calculator and give me 3SF. So even if you get in your calculator, the answer is 2 in your calculator, you are not allowed to write 2. You have to use 2.00. Okay, always give in 3SF. Okay, this is a must for your O-level. Okay, for the next thing, the next question asks you to find net force. So for those of you who have memorized the formula sheet religiously, right, you will know that F net, remember to write down this small word net, is equals to MA. So F net is the one that we want to find, and we already know that your mass is 500. So now you may ask me, teacher, what is A? So remember, when you are doing your formula memorization, you will have come across this thing called speed time graph. So I hope you remember that the gradient of your speed time graph is equals to what? Yes, your gradient of your speed time graph is actually equals to your acceleration. Okay, so you have already found the acceleration from answer of B. So actually what you need to substitute down here inside is just answer of B. Okay, and you will get your answer. And remember 3SF. So when you write down here, you also notice that for O-level, they don't give you the unit. So you need to give your answer in 3SF and remember to put in the unit. Okay, then you may ask me, teacher, then how about part B? Does gradient has a unit? Okay, gradient has no unit. Okay, unless they are asking you for acceleration. Then acceleration, if you do not know the unit, ask Ernest. Okay, he will know. Okay, for this part, a lot of you are getting it wrong. And you are getting it wrong because you are too used to the N-level syllabus. You always minus. Okay, so what happened is that for O-level, you can no longer do that. You need to write it down properly, slowly and religiously follow my method. So now you are being asked how to find total resistive force. So the first thing come into your mind is, got formula or not? If you find that you cannot recall any formula and you start to panic, don't worry, there's no formula. So you have to write. The other thing that you know is that F net is also equals to sum of forces. So how many forces are here? We have driving force, we have resistive force. So write down. Don't panic or skip steps. Go and write down, okay, I have my driving force. Okay, sum, right? So plus resistive force. Okay, equals to your F net. Okay, remember force is a factor. So if they are in different direction, there will be a negative sign. So if you ask me, okay, the resultant force and the driving force is definitely in the same direction because your car is moving forward, right? So you will have your driving force and then you have your resistive force. Your F net and your driving force is in the same direction. So because of that, they are both positive. How about your resistive force? Your resistive force here is in the other direction, meaning that if I simplify it, it will become F net, which is your answer in C, correct? And driving force, we do not know, so we will keep it here, driving force, plus your resistive force is 400, but remember it is in the negative, in the opposite direction, so therefore it has a negative sign like that. So when you bring over and you want to find now your driving force, when you want to shift this guy over, you will actually end up with answer C. Then what? Very good. You will get plus 400. Okay? Yeah, so therefore the answer here you will get is your answer in C plus 400 Newton. Okay, so that's how you do it. Okay, for the next question, you are supposed to draw the resultant force of tension and weight. Okay, so basically what I always teach you guys is draw it on this thing first. So you have the weight. Okay, do I know the weight? Well, the answer is here. The mass is 6 kg. So the weight will be 6 times 10, 60 Newton. And I also want to draw the tension of 80 Newton. Remember, your tension is always along the string and is always pulling it up. So this is your tension, 80 Newton. Okay, you also know that for this, you are 40 degree here. So I will always suggest you go and do your alternate angle. So this is with the vertical. This is called the vertical. Okay, so alternate angle, it will be this angle here will also be 40 degree. So let's say I want to draw my diagram now. First thing, I will do my scale. Okay, since I have like that, I think I will do 20 Newton 1 cm. So this guy here will be 3 cm. This guy here will be 4 cm. It's very manageable. So unfortunately, my iPad doesn't allow me to draw to exact. So I will try my best. So this time round, let's say I do approach 1. I will show you both approach. Okay, let me get my protractor. Where's my protractor? Oh, here. So I will start for approach 1. I will draw my weight followed by my tension. Okay, so weight is very simple. Weight is one straight line. So this is my start point. I will draw 3 cm down. So I will draw 3 cm down, 0, 1, 2, 3. So I will do, I will do 0, 1, 2, 3. I will do like that. Okay, why? How come? Okay. Hey, what is happening? Draw mode. And I want to draw. Okay. 1, 2, 3 cm. So I stop here. This is my W, is going down. Okay, then from here, the next thing I need to draw is my tension. So I will do a bearing here. Make it easier for me to measure the angle. Okay, so I will use dotted line. Okay, then I want to draw now my 80 Newton here. And I know this 80 Newton, right, will measure down here 40 cm, 40 degree because of this down here on top. Can see this part? Let's use green. Okay, now I'm doing this. I want to do this 40 degree. So I will put my projector on my iPad and I will draw 40, 0, 1, 0, 10, 20, 30, 40. 40 is here. So then I will take away my projector and I will draw this line here. And I need to measure 80 Newton, right? So I will measure 80 Newton, which is 4 cm 0, 1, 2, 3, 4. It will end somewhere here. So it ends somewhere here. This is my tension. So where is my resultant? My resultant is from start to end. And I will draw my double arrow. Can? Let me check, did I do any mistake? 0, 10, 20, 30, 40. Okay, correct. So my answer here would be about 3.3 cm. So my resultant will be 3.3 cm. So it is about times 20 Newton. 3.3 times 20 Newton, 66, is it? 66 Newton. Okay, and how do I know what is the direction? Well, the direction will be here, right? This angle. So if I put my projector there, the measure is around 15 degree. So I would say that this guy is 15 degree from the horizontal. Okay, so this is approach 1. What is the approach 2? Let's say if I do it again, but this time round, I want to draw my tension first, and then I want to do the weight. So tension first, I want to start here because I know that I'm going to draw upward towards the northwest position. So same thing, once I know this is where I start, I will want to draw a bearing here so that it's easier to measure. Okay, then I will measure 40 degree from the vertical. So 0, 1, 0, 10, 20, 30, 40. 40 is there. Then I will take my pen and I draw my 40 line. Draw, 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 draw. So I know here is 40 degree. Then now I need to measure the 4 cm here, right? Because tension is 4 cm. So I take this, measure 4 cm. Okay, and I know the tension is this way. Correct? Then after that, I need to draw my weight. And remember head to tail, so I will start here. So weight is downwards 3 cm. So I will do downwards 3 cm. Yeah? Up, down, downward 3 cm. And my resultant is this. How come so funny, ah? Did I make any mistake? It should be the same. Let me check. Let me check approach 1. The weight is 3 cm. Weight is 3 cm, correct. The weight 3 cm. Then my tension is 4 cm. Oh, I know why. So sorry. My down here is wrong. Sorry, let me check. Let me erase the thing. Stroke eraser. Yep, this is wrong. Because my tension is supposed to be 4 cm, right? I actually used my ruler wrong. 4 cm, if I draw right, is around here. Okay, so actually it should stop here. And so my resultant is here. Can? So therefore you have this. This is my resultant. Okay, so when I join this, let me get, this is about 2.5 like that. Okay, maybe on yours it's not 2.5, but don't worry, because I'm drawing on iPad, so this value may not be the same as yours. So 2.5 times 20 is 50 Newton, and to this side, it is to the left, right? And you can see both methods will give you the same result, okay? Okay, for your part B, a lot of you got it wrong. The resultant force is now to the left, right? But look at what the question is saying. Determine the direction of a force needed to keep the ball from swinging down. Keep the ball from swinging down. So which is the force that is responsible for this ball to swing down? If you look at the free body diagram, your ball is like that, right? Okay, and it is swinging down. Why is it swinging down? It's because look at your resultant force. This resultant force and this resultant force. Because your resultant force is going this way, right? This is your resultant of W and T, correct or not? So in order to keep the ball from swinging down, what you need to do, you need to introduce a force that is exactly opposite of this resultant force, right? So actually your force to keep it from swinging down should be the same value but opposite direction. Okay, so this is how you need to do this question. Of course, the question only requires you to talk about the direction. You need not talk about the value, but I'm just telling you this thing. Okay? So I will stop here for a pause.